Today we are going to look at a schematic representation of two resistors connected in parallel. In this arrangement, we are expected to calculate the total heat energy developed in 5 minutes in the circuit drawn below. This is the circuit, alright? So that's what we are expected to do. We need to find out what happens here. We want to calculate heat developed in 5 minutes in this circuit, alright? Alright, this is the formula we're going to use to find the heat developed in this circuit. But first of all, we need to do brief explanation of what happens within this circuit. This is the cell of 10 volts, supplies current, especially now that the key is closed. Current flows, this current flowing. At this juncture, the current splits into two. The other part flows into resistor 4 and the other part flows into resistor 2, and they recombine at this point. They recombine at this point and flow down back to the source once again. So that's what actually happens. And we should also know that resistors connected in parallel always assume different current values, alright, but the same voltage values. So that is what we are going to know about that. So let's quickly calculate the total resistance offered in a parallel section. So calculating that is 1 all over RT is equals to 1 all over R1 plus 1 all over R2, representing first resistor with its resistance 4 ohms, second resistor with its resistance 2 ohms respectively. That's what this represents. So we can quickly substitute accordingly. For 1 over R1, 1 over R1 is going to be 4, that is 1 all over 4. And then for 1 all over R2 is going to be 1 all over 2, that is 1 all over 2. The two resistances have been represented. So the next thing we need to do is to quickly calculate. Okay? We want to find the total resistance first so that we can get this. Alright? And that gives us the LCM. We find what we call the LCM. The LCM of 4 and 2 is 4. Right? 4 divided itself is going to be 1 times 1, this. Right? We put our plus sign. 2 divided 4 is going to get 2, and 2 times this is going to be 2. Right, so we have 3 all over 4. Alright? But it doesn't end there. It doesn't end there. So the next thing we recall that we have inverse of RT is equal, so we bring this down, 3 all over 4. So what we need to do here, to remove this 1 over RT, to remove the 1, we need to introduce the inverse to both sides, okay? So inverse at this point, inverse also at this point. Alright? And that invariably is going to give us a RT, because this inverse will take care of 1, cancels out. And this is going to invert this to become 4 all over 3. Alright? Okay? So if we take the decimal value of this, the decimal equivalent of this fraction, it becomes 1.33 ohms, right? Okay, so with this, the total resistance RT, is equal to 1.33 ohms. Found. So we have found that. Okay, that's okay, and this is what we're going to substitute here. All right, all right. So if you have watched up to this moment, it is time for you to subscribe, okay? Give us some thumbs up, right? Give us some thumbs up to increase the matrix of this video. At the same time, share with your networks, share with your friends, share with your students. Let them know that there is a video like this that clearly explains how problems can be solved. All right, let's also remember to put on the bell button for constant notification. I remember to say this. Put on the bell button for constant notification each time content like this are uploaded. you'll be among first set of individuals to be notified, right? That's great. All right, so let's move on. There's something we need to, they say 5 minutes. 5 minutes, we need to convert that. Time given is 5 minutes. All right, so we need to convert this to seconds. We need to take this to seconds. All right, so how do we do that? Time is equals to 5. 60 seconds make a minute. So we multiply 5 by 60, and that will give us 300 seconds. All right, that will give us 300 seconds at this point. Now our t is equal to 300 seconds. Okay, that is it. So 300 seconds is equivalent to 5 minutes. All right, that's what it means. We have T, we have total resistance. That is T total resistance. Already the current is given as I. Okay, so what do? We now gather our parameters very wisely. So our T is given, our current is given as 1.2 amps, right? And then resistance. The resistance is given as RT is equals to 1.33 ohms. So with these values, we substitute. Where we have current, we substitute. Where we have resistance, we substitute. And where we have time, we substitute. And then simplify. Whatever we arrive at is the answer. So let's quickly do that here, right? So we have our, to calculate the heat developed in this circuit, we use the H equals to I squared, right? R and then T. Okay, we substitute. For I, we have 1.2 and then squared. For R, we have 1.3, okay? And then for T, we have 300 seconds, okay? Okay, let's rewrite this. It's too squeezed up at this point. Let's rewrite it for clarity purpose. Now we're going to use this relation to find the amount of heat that is generated in these circuits. Okay, so for current we have 1.2 and then all squared. For resistance we have 1.3, excuse me. All right, that's for resistance. Current is 1.2 squared. Resistance is what we already have here, 1.33, and then the time we converted is going to be 300 seconds. This can be here, 1.2 amps, okay? All right, so with these we continue. We continue here. So what we have here is going to be 1.44, right? And then we have 1.33, and then we have 300, okay? So by the time we finish everything, I want you to do this. I want you to find out, all right? Find out this, and then put it in the comment section. What the values will be. 1.44 times 1.33 times 300 seconds, which represent the time. What are you going to get? All right? Do this. This is a little simplification, simple calculation. Do that. And then remember, heat is measured in joules, right? So this the joules is the symbol, okay? It's measured in joules. So I want you to fill in this. Put it in the comment section to tell me. That will show that you actually watch this video from beginning to the end. Good luck. Don't forget, subscribe. Give us some thumbs up. And then share with your friends, with your networks, with your students. Let them know. Who knows, you're helping somebody somewhere. And then remember to put on the bell button for constant notification each time something like this is uploaded. You'll be among first set of individuals to be notified. See you in my next class.